Hi guys, and welcome back to the video series on ODEs. And in this video, we will be talking about the substitution method. So this substitution method is the third of the 5 methods that we'll be going through for ODEs. And when do we use this substitution method? It's when we have differential equations which can be expressed as a function of y over x. And in other words, we'll call these equations homogeneous equations. What substitutions do we use, since the name of this technique is substitution, right? Okay. We will use the substitution y equals to vx. And since the homogeneous equation can be expressed in the form of y over x's, like all the terms in maybe descending powers of y over x, we can substitute out our y over x equals to v. Alright, which is quite much derived from the y equals to vx substitution. Secondly, dy dx, how are we going to sub that out with this new substitution? So we are going to differentiate y equals to vx in terms of x to give us dy dx equals to v plus x dv dx. Okay, so a bit of recap on the implicit differentiation skills. How do you differentiate v in terms of x using a bit of product rule as well? Okay. And after this substitution, once we have substituted the whole homogeneous using this highlighted yellow substitution, we should only have a differential equation in terms of v and x. No more y's, alright? So y's are removed and left with v and x. From there on, which is why I mentioned that this method is quite closely tied to the variable separable method in the previous video, because after substitution, we will just use the variable separable method to simplify the DE and solve it from there. Last but not least, please do not forget to sub back out all the v's equals to y over x, so that our final answer will only have y's and x's, because the question did not give us a v. The v was introduced by us using this method. Alright, so let's take a look at some examples. First question. Solve the dE dy dx equals to x plus y over x. First step, it's always to simplify this equation to make it into like a homogeneous form where we can see y over x. In this case, y over x hasn't really popped out yet. So let's simplify it a little bit more. dy dx equals to 1 plus y over x. Right, so that's how we can simplify it, and now you can see that the y over x has popped out. And we can say it's quite much a homogeneous equation. We are ready to substitute. Using the v substitution, dy dx, refer to the top, equals to v plus x dv dx. So equals to v plus x dv dx. How about the right hand side? 1 will stay as 1. Y over x, since we are using y equals to vx, y over x will equals to v. So we sub that out. And because of this substitution, the equation has become a variable separable equation. And as such, we can simplify it to separate the variables before integrating. Firstly, there are v's on both sides of the equation, so we can quite much remove those two, right? The v's will cancel off over here and over here, so we can cancel them off, which leaves us with x dv over dx equals to 1. Yes, this looks quite familiar to the variable separable questions we did in the previous video. As such, we will be bringing over the x to the right hand side, leaving us with this dv dx equals to 1 over x. Integrating both sides with respect to x, we will have dv dx dx equals to integral of 1 over x dx. Okay, we can quite much put a 1 on the left hand side lah. Okay, it's the same thing. So then we will have integrate 1 dv equals to integrate 1 over x dx, and we can integrate from there on. V equals to ln mod x plus c, where c is any arbitrary constant. Once again, don't forget to sub back out the v, so we use v equals to y over x and make y the subject. As such, we have this x ln mod x plus cx. That is our final answer for the first question. Now let's take a look at the second question. Second question, find the particular solution given the initial condition when x equals to 1, y equals to 1. So the dE we are given is dy dx equals to y squared plus x squared over xy. Once again, you don't really see the y over x pop out just yet. As such, we will need to split the fraction a little bit more. So let's simplify it a bit more first. dy dx equals to y squared over xy plus x squared over xy. And let's simplify the right hand side one more step. We will have y over x plus x over y. So x over y, how can we make it into the form of y over x? Okay, you can use the power of -1 to reciprocate it. So dy dx equals to y over x plus y over x -1 power. And let's once again substitute the v. So we have v plus x dv dx equals to v plus v power -1. From here we can cancel off the v's on both sides again because both has a plus v, which leaves us with a v power -1. Or for clarity's sake we can put it as 1 over v. Now we can separate our variables, which leaves us with v dv dx equals to 1 over x. Integrating both sides with respect to x, variable separable method, we can have integrate v dv equals to integral of 1 over x dx. Very nicely we have a v squared over 2 equals to ln mod x plus c, where c ... define the c constant once again. Remember to sub out the v for y over x. We'll have y squared over x squared, okay, multiplied to half equals to ln mod x plus c. Now let's make y the subject, so we can start by multiplying throughout by 2. So we have y squared over x squared equals to 2 ln mod x. Since it's just a constant multiplied, we just leave it as c. And so we will multiply throughout by x squared, leaving us with y squared equals to 2x squared ln mod x plus cx squared. And now given the information that y1 equals to 1, okay, so we will have 1 equals to ln 1 equals to 0, so the whole term's gone, and then we have c. So c equals to 1. Substitute that back, y squared equals to 2x squared ln x plus x squared. And you can factorize out the x squared on the right hand side to give you 2 ln mod x plus 1. And that is the final answer. So these are two examples of some substitution questions. Main thing is to be able to recognize the form, modify it such that you can get y out of x popping out like the fractions, and then you can substitute them for your v. And recall, last step is just to substitute back from your v world back into your y over x and simplify to get your answer. Alright, with that, hopefully from this video, you got a better understanding of the substitution method that we use for our homogeneous equations. And thank you for watching this video. I'll see you in the next video for the integrating factor method. Peace out.